sulfate. Sorry, the video got iron sulfate would be iron 2 sulfate would be also balanced out because both of them are divalent, so that would be just 1 each, because when the 2 comes down here, this 2 goes here, it becomes balanced out and empiricity rules. But however, if it were iron 3 trying to react with sulfate ions that remain a constant of divalent, they have a constant valency of 2 negative, it'll be Fe2 SO4 3. So which means 2 iron are coordinating to form this bond, and that's why 2 of these are required to nullify 3 of those. However, if it's now bear in mind these are iron 3, not iron 2, so if it's iron 2, only one of it shall suffice. Okay, let's take, so here's a valency table. We've got positive monovalent ions that are hydrogen, ammonium, potassium, sodium, silver, copper 1. Then we've got divalent positive metallic ions, which are cations. So it's barium, calcium, copper, ferrum, iron, lead, magnesium, zinc, aluminium, and then it moves on to trivalent. There aren't any tetravalent because those are part of advanced D block elements, transition metals. So aluminium and iron are trivalent. So ions exhibiting variable valency like copper. And now we come over to anions, which we have a list, a comparatively brief list, which starts from hydroxide to nitrate to chloride, bromide, iodide, then hydrogen hydride, we call it hydrate, then bicarbonate, oxygen, sulfur, sulfate, sulfate and carbonate, and then phosphate. So this is how compounds are formed. You need to understand the cross valency, the cross multiplication, and now we need to calculate the relative atomic mass and learn the difference between RAM and RMM. So we'll do simple examples. We'll start off from the relative atomic mass. So the relative atomic mass of chlorine is an averaged out 35.5 grams per mole. Whenever you're measuring RAM or RMM, it has to be in grams per mole. It can't be in kgs per mole. Nope. It can't be in tons per mole. It can't be in milligrams per mole or micrograms per mole. Nope, it cannot, will not, because it's supposed to be in grams per mole. Grams per mole. And when there is 1 mole of that compound or element, it's just simply grams. It's just 1 mole of that element or compound. So we'll do carbon dioxide first. So in this molecule of carbon, we've got carbon dioxide, we've got 1 atom of carbon and 2 atoms of oxygen. And we know that the relative atomic mass of carbon is the relative atomic mass of carbon, which is the top part. The relative atomic mass is the sum of the is equivalent to the nucleon number, so you have to always look at the top or look at the bigger figure, because some of the silly putties, they used to put the heavier number at the bottom in the past. In some books I saw, it's ridiculous, but you always pick the largest number. So that's 12, and for oxygen it'll be 16. So that's 12 grams per mole. Notice I'm using the mole unit, grams per mole, plus 2 into 16 grams per mole. That'll be 12 grams per mole plus 32 grams per mole. So that'll be 44 grams per mole. If I'm just doing it, these 2 steps were extra, so you could jump over to 44 grams per mole if your mental maths is good. So so the relative atomic mass, relative molecular mass, and for carbon dioxide is 44 grams per mole. Now, please remember, and do not make this mistake for the sake of your own sanity. Relative atomic mass is for elements. Like carbon, phosphorus, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, gold, palladium, platinum, silver, and relative molecular mass is for compounds like water, oxygen, carbon dioxide, nitrogen, nitric acid, sulfuric acid, hydrochloric acid, ammonium chloride, ammonium sulfate, ammonia, and the list goes on, all the way to transition metals, ionic, dendritic complexes. So RAM, relative atomic mass, is to elements, as relative molecular mass is to compounds. Okay, so I'll demonstrate an example for the calculation by using sodium chloride followed by Calcul2 followed by aluminium sulfate. So I'll increase the complexity. So I'll start off by using so I'll do sodium chloride first. Sodium would be 23 grams per mole plus 35 grams per mole, 35.5, sorry. That's the average of its isotopes. So that'll be 58 grams per mole, GMOL inverse -1. So I write moles, grams per mole, as this. Now, you are more than welcome to write it as grams as grams per mole, / mole, but I write it as inverse because it's easier and there's no need for this. The second one I'd like to do is Calcul2. I call it Calcul2. This calcium chloride, calcium 2 chloride. It's known as calcium 2 chloride. That's its IUPAC name. Now, calcium chloride would be 1 atom of calcium and 2 atoms of chlorine. So that'll be 40 grams per mole plus 2 into 35 grams per mole, and that'll be 40 grams per mole plus 71 grams per mole. That's 111, 1 Nelson grams per mole. So that we've got it now. So that's very interesting. And as you continue to practice and play around with the RMMs of different compounds, you begin to remember a few of them. That's how things are like sodium carbonate, sodium bicarbonate, Calculational, sodium chloride. They become part of your daily route, and you begin to remember them. The next one I'd like to do is aluminium sulfate. You might remember I did this for you in the valency section in the previous video, which was accidentally switched off. Apologies. So that will be 2 atoms of aluminium plus 3 atoms of sulfur, see, plus 12 atoms of oxygen, brackets, so that the examiner doesn't think you've put 120 here. And I make S quite distinct. So we know that aluminium is, where's aluminium? 27, so that'll be 2 times 27 grams per mole, plus sulfur would be 3 into 32 grams per mole, plus 12 into 16. That's interesting. 12 into 16 grams per mole. You don't need to show every step. However, if it's a 5-mark question, I suggest you do. 54 grams per mole. Sorry, then 696 grams per mole. And 12 times 16 is rough work. Time for a bit of rough work. That's that. And so now we add all of it. So that'll be 140, 150, 250, 340. So that'll be 342 grams per mole. (342 grams per mole). 342 grams per mole. And that's that. So I hope you are with me and you follow the sequence. So aluminium sulfate, 2 atoms of aluminium, 3 atoms of sulfur, 12 atoms of oxygen. I hope you understand. Let's not beat around the obvious. 2 times 27 grams per mole plus 3 times 32 grams per mole plus 12 times 16 grams per mole. You do the maths, you get 342 grams per mole, which means 342 grams of aluminium sulfate would constitute 1 mole of aluminium sulfate. So 111 grams of Calculational would constitute 1 mole of Calculational. 58.5 grams of sodium chloride would constitute 1 mole of sodium chloride, hence the word mole. Now we move over to this is a plethora of practice here. So I'm going to start off greedily. I'll start off with So2 Sulfur Dioxide. So sulfur dioxide is 1 grams, 64 grams per mole, which means 64 grams of this gas, pure gas, will constitute as 1 mole, containing the Avogadro number of particles, which means it would have 6.02 10 to the power 23 molecules of sulfur dioxide in 64 grams of sulfur dioxide, pure sulfur dioxide, with no other atoms or molecules of any other chemical or element or a compound, and it would be constituted as 1 mole of that gas. So, and then we do magnesium carbonate, which is 1 atom of magnesium plus 1 atom of carbon plus 3 atoms of oxygen. And that's magnesium here is 24, so that's 24 grams per mole, plus 12 grams per mole, plus 3 into 16, 48 grams per mole. That's 36 and 40, 44 and 84. That'll be 20, 30, so that's 70, 80, 84, that'll be 84 grams per mole. The next one is magnesium nitrate, which is 1 atom of magnesium, 2 atoms of nitrogen plus 6 atoms of oxygen. So that'll be 24 grams per mole, plus 2 into nitrogen is 14, so 28 grams per mole, plus 6, 16, 96. 6 times 16 is 96 grams per mole. And so that'll be, so I'll take 4 and I add here 100, 120, 148. So 20, 40, 130, 136, 40, 148. You have 148 grams per mole. That's the relative atomic molecular mass of magnesium nitrate. We'll go over to sulfuric acid, the king of acids. That's 2 H atoms plus 1 sulfur atoms and 4 oxygen atoms. So that's 2 grams per mole, because hydrogen is 1 grams per mole, and that's 32 grams per mole. Sulfur, let me just double check. Sulfur is 32 grams per mole, that's correct. And then 4 times 16 is 64, 64 grams per mole. So that's 2 plus 32, 34, and then 98. So that's 16, 90, 92, 94, 98. So that's 98 grams per mole, which means 98 grams of pure sulfuric acid would constitute 1 mole of sulfuric acid, and it would contain the Avogadro number of sulfuric acid ionic constituents. So the next one is calcium sulfate. I'm sorry about the sulfate repetition, but I have to. Sorry, it's yes, calcium sulfate. So I'll do copper sulfate next. Calcium is 1, and we have 1 sulfur, and we have 4 oxygen. So that will be 40 grams per mole, 32 grams per mole, plus 64 grams. We have to mention grams per mole, grams per mole, grams per mole, because some of them are grams per mole, whilst this one isn't. It's not grams per mole, but I'm having to mention it to maintain dimensional homogeneity. So that'll be 72, 70, hang on, so 90, 130, 132, 136. So that's 40, 70, 70, and 130, 136, yes. So that'll be the 136 grams per mole would be, so 136 grams of chalk will constitute as 1 mole of calcium sulfate. I'll do copper sulfate next. 1 atom of copper, 1 atom of sulfur, 4 atoms of oxygen. Then we do 64. It's 63.5 because of his isotopic averaging in mass spectroscopy, but you know, let's just call it 64 for now. And then 32 grams per mole plus 4 times 16, 64 grams per mole. And then so that's 96, 100, 160, so that's 160 grams per mole. Copper sulfate is used in a lot of calculations, especially copper sulfate pentahydrate. So that's double check: 60, 90, 150, 154, 156, 60. Yeah, that's correct. So that's the relative molecular mass of. Now we do sodium carbonate. So that's 2 atoms of sodium plus 1 atom of carbon and 3 atoms of oxygen. We can't do 3O because it would look like 30. So you have to do it like this. So that will be 46 grams per mole because sodium is 23 grams per mole. And carbon would be 12 grams per mole. And oxygen would be 48 grams per mole. So we add all of it, we get 58, 66, 106. So 46, double check, 40, 50, 90, 98, 100, 106. So that is correct. So the lattice, 106 grams of sodium carbonate would constitute as 1 mole, and it would contain 106 grams would contain 6.02 times 10 to the power 23 ionic components, ionic composition, ionic lattices, ionic constituents of sodium carbonate. So there are lattice contains many more. So now we do iron 3 sulfate. That'll be 2 atoms of iron, 3 atoms of sulfur, and 12 atoms of oxygen. I think we did it just now. So iron is 56, so that'll be 112 grams per mole. This will be 64 grams per mole, and that'll be 12 times 16, 12 times 16. $190. Two. That'll be 110, 190, that's 300, 304, 308, 368 grams per mole. So that's 368 grams of iron 3 sulfate would constitute 1 mole. And so that's that. 368 grams of iron 2 sulfate whole thrice would be 1 mole of this compound. So that's how things are. And then we do sodium hydroxide. Sodium, 1 atom of sodium, 1 atom of oxygen, and 1 atom of hydrogen. So that will be 23 grams per mole plus 16 grams per mole plus 1 grams per mole. I'm not using GM because M is the common factor, so GMOL inverse 1 would suffice. So that's 23 and 17, that's 40 grams per mole. So 40 grams of solid sodium hydroxide would constitute as 1 mole. Now we do KOH, potassium hydroxide. That would be, potassium is 39. So that'll be 1 atom of potassium, 1 atom of oxygen, 1 atom of hydrogen. It'll be 39 grams per mole plus 16 grams per mole plus 1 grams per mole. That would be 55, 56 grams per mole. Okay, and now then we do lithium hydroxide. It's 1 atom of lithium. I hope you're getting the pattern now. 1 atom of oxygen and 1 atom of hydrogen. So that'll be lithium is 7 grams per mole. Oxygen is 16 grams per mole. Hydrogen is 1 grams per mole. And that'll be 8 and 24 grams per mole. So 24 grams of solid lithium hydroxide without any contamination of water particles, water molecules, shall constitute 1 mole of lithium hydroxide. Then we would do calcium hydroxide, which is divalent. 1 atom of calcium, 2 atoms of oxygen, and 2 atoms of hydrogen. That'll be 40 grams per mole, 32 grams per mole, 2 grams per mole. That'll be 72, 74 grams per mole. That's sorted. So 74 grams of 1 mole, 74 grams of calcium hydroxide, solid calcium hydroxide without any contamination or water, hydrostat. It would be considered 1 mole of calcium hydroxide. So yeah, that's that. And so RMM of calcium hydroxide is equal to 74 grams per mole. There we go, that's how it is. 40 plus 32, that's 72, plus 2, that's 74. And now we do magnesium hydroxide. That would be 1 atom of magnesium, 1 atom, 2 atoms of oxygen plus 2 atoms of hydrogen. That'll be 24 grams per mole plus 32 grams per mole plus 2 grams per mole. That'll be 26, 28, 58. So 20 and 30, 50. 54 to 2, that 58 grams per mole. It's only 0.5 grams less than sodium chloride's relative molecular mass, which is quite interesting. And then you have lead 2 chloride, which would be 1 atom of lead and 2 atoms of chlorine, which we know that lead is, where's lead? 207. Plus 2 into 35.5 grams per mole. That'll be 207 grams per mole plus 71 grams per mole. That'll be 278 grams per mole. So that'll be 278 grams per mole. .278 grams of lead 2 chloride would constitute as 1 mole. And the next one we've got for you is zinc hydroxide. 1 atom of zinc, 2 atoms of oxygen, 2 atoms of hydrogen. And zinc we know is, I think, 65. Yeah, 65. And I'm just trying to be humble. I know I remember these, but for your sake, in order to work through as an equipartisan, I'm trying to be humble and pretending I don't remember it, but I remember it. But it's 65 grams per mole, 32 grams per mole, and 2 grams per mole. That'll be 95, 97, 99. Wow, 99 grams per mole. So 65, that's 95, 97, 99. So that's 99 grams per mole of zinc. That's very nice. So 99 grams of hydroxide equals 1 mole. There we go. Then we do nitric acid. So 1 atom of hydrogen, 1 atom of nitrogen, plus 3 atoms of oxygen. So that's 1 grams per mole, 14 grams per mole, and 48 grams per mole, right? So that's 15, and that'll be 63 grams per mole. So 63 grams of pure non-diluted nitric acid would constitute as 1 mole of nitric acid. Then we've got lead tetraoxide. I think, yeah, lead tetraoxide. That'll be tri-lead tetraoxide. So that's 3 atoms of lead and 4 atoms of oxygen. That's 3 times 2, or 7 grams per mole, just to show you working, and then 64 grams per mole. That's 621 grams per mole plus 64 grams per mole. That'll be 685 grams per mole. So that's interesting. It's quite a large lattice, if I may say so. And then the next one I'd like to go for is a calcium bicarbonate. Why? Because bicarbonates are -1 and calcium is divalent, so this is how it constitutes. 1 atom of calcium, 2 atoms of hydrogen, 2 atoms of carbon, plus 6 atoms of oxygen. So that's 40 grams per mole, 2 grams per mole, 24 grams per mole, and 72 grams per mole. So that's 40, 60, 130, 132, 136, 138, 138. So calcium, 1 calcium, 2 hydrogen, 2 carbon, 6 oxygen, 40 plus 2 plus 24 plus 72, so that's 70, 90, 130, 132, 136, 138 grams per mole. And then we do sodium. Now here's a twist: Na2co3 Decahydrate. So this is what you call a soaked powder, where it forms a temporary hydrogen and temporary bonds with the water molecules. So that'll be temporary bonds. So these are temporary bond formations. So we've got 2 atoms of sodium, 1 atom of carbon, 3 atoms of oxygen, and 20 atoms of hydrogen, and 10 atoms of oxygen. So now we further simplify it. So 2 atoms of sodium plus 1 atom of carbon. So we've got 3, and then 13 atoms of oxygen, and 20 atoms of hydrogen, which is basically just 20 grams per mole. So that'll be 46 grams per mole plus 12 grams per mole plus 13 times 12 plus 156 grams per mole plus 20 grams per mole. We've got it now. So 46 and 12 and then 156 and 20. So we'll do 150 and 20 is 170, 170, 180, 220, 226, 228, 228 and 234. Check again. 46 and 12 is 58. 58 and 20, 78, 78 and 51, 28, 100, 228, 234. So that's correct. So the relative molecular mass for sodium carbonate decahydrate is 234 grams per mole. Now we do potassium nitrate. One atom of potassium, one atom of nitrogen, and 3 atoms of oxygen, and that'll be 39 grams per mole plus 14 grams per mole plus 48 grams per mole. And then we do 53 and 48, so that's 30, 40, 80, 88, 92, 101. That's 101 grams per mole. 39 and 14 is 53, 53 and 8 is 61, 101, so that's correct. The next one is magnesium chloride. And that's 1 atom of magnesium and 2 atoms of chlorine. I've written it in an ionic fashion so that you can understand that it's just the same thing, no need to freak out. So that'll be 24 grams per mole, per mole for magnesium, and 2 into 35 grams per mole for chlorine. So that'll be 24 grams per mole plus 71 grams per mole, and that'll be 95. So 95 grams of magnesium chloride, pure magnesium chloride without any contamination, would constitute as 1 mole of magnesium chloride. Then we do zinc sulfate. Zinc sulfate would be 1 atom of zinc plus 1 atom of sulfur, 4 atoms of oxygen, so 65 grams per mole, 32 grams per mole, and 64 grams per mole. So that'll be 97, 101, 161. So 63, 90, and then 150, 154, 156, 161. Yes, that is correct. Reverse check. Always reverse check. So add this way and then this way. Right, and then you do magnesium sulfate heptahydrate. Why? Because it's got salt. It's got 7 water molecules here, so that'll be 1 atom of magnesium, 1 atom of sulfur, 14 atoms of hydrogen, and 11 atoms of oxygen. You can see, because 7 times O plus 4 times O, that's 11 times O, right? So that's that, and that'll be 24 grams per mole plus 32 grams per mole plus 14 grams per mole, and that'll be oxygen would be 176 grams per mole. So that's 20, 30, 50, 60, 60, and 170 is 230, 236, 240, 242, 246. Let's just double check it. 24 plus 32 is 56, and then that's 70, and then 170, 70 is 240, 246. Yeah, that should be correct. 170, 180, 210, 230, 234, 236, 240, 246. Yes, that is correct. And then we do diphosphorus penta oxide. Diphosphorus penta oxide. That'll be see the ionic equation? That's how you do it. So diphos pentoxide. That's how you write it in short terms. Diphos pentoxide. Diphos pentoxide. Pent oxide. There we go. And it would be 2 atoms of phosphorus, 5 atoms of oxygen. And phosphorus, for your convenience, is 31. So that's 31 grams per mole plus 80 grams per mole. And that'll be 111 grams per mole. Wow. So yeah, is that true? 80 and 31. Yeah. So the relative atomic mass of diphos pentoxide is equal to Kcal2. Interesting, isn't it? So that's why in chemistry you just don't go by the mass. You have to look at the physical and the chemical features of the compound as well, the color, the physical, and the chemical features. So it's interesting. The relative molecular mass of diphos pentoxide is equal to Kcal2. Interesting finding. We've discovered something just now for our own personal use. All right, let's do the very popular copper sulfate Penta hydrate. Okay, so that's how it is. And so you've got 1 atom of copper, 1 atom of sulfur, 1 atom of so 10 atoms of hydrogen, and 5 and 4, 9 atoms of oxygen. So that'll be 64 grams per mole, plus 32 grams per mole, plus 10 grams per mole, plus 9 into 16 would be 160 minus 160 minus 16, that'll be 144. 144 grams per mole. So we can add all of it. That'll be 60, 30, 90, 100, 140, and 240, 244, 246, 250. Exactly 250 grams per mole, and I remember it's correct. So 250 grams of copper sulfate pentahydrate would constitute as 1 mole, and it's blue in color. It's blue powder. Hydrated powder is blue. Okay, so now we do iron 2 sulfate. Heptahydrate. That'll be iron sulfate 2 sulfate, which is balanced valency, 7H2O, right? So that'll be iron sulfate plus 7H2O. Now we've got 1 atom of iron, 1 atom of sulfur, 14 atoms of hydrogen, and 4 and 7, 11 atoms of oxygen. Okay, 11 atoms of oxygen. So iron sulfate heptahydrate, 1 iron, 1 sulfur, 14 hydrogen, and 4 and 7, 11. So then we do 56 grams per mole, 32 grams per mole plus 14 grams per mole, and 11 times 16 is 176. So that's 176 grams per mole. Now we add all of it, we get 50, 80, 90, 190, and then 260, 266, 270, 270, 278. 278 grams per mole. Let's double check. That's 170, 180, 210, 260, 266, 268, 272, 278. So that's correct. So the relative molecular mass of iron sulfate heptahydrate, not just iron sulfate, rather all of the molecular lattice with temporary bond, iron sulfate heptahydrate would be 278 grams per mole under IUPAC conditions and standard temperature pressure or RTP, whichever you choose. Whereas STP and RTP is more for gases, not for solids and liquids. So thanks ever so much for watching this. This was my video, a long sought after, long awaited, and a long time coming video that would summate the concept of relative atomic mass, mole, and relative molecular mass. And I wanted to do a video in which I'd encompass and include as many compounds as possible, and I'm grateful you stuck by and you were patient. And if you have any questions, please post them down in the comment sections below and I'll try my best to answer it. And yeah, I hope you have a great winter. Winter's coming, and yeah, make the most of it, and wish you all the best. Take care. Bye now.